Hello everyone, myself Dr. GBVS Lakshmi, working as a postdoctoral fellow at a Special Center for Nanoscience, Jawaharlal Nehru University, New Delhi. And today I am going to present my work on the fabrication of disposable, environmental friendly, cost effective, paper based cholesterol biosensor. It is disposable because it is made on the paper, that is ivory sheet we have used, and it is environmental friendly because the ink used in this fabrication is carbon ink, which is environmental friendly, and the paper, which is also environmental friendly and biodegradable, and it is cost effective, and it is based on the electrochemical technique. As we all know that electrochemical technique is the best technique for developing a sensing device. The outline of my presentation will be, I will give a few small introduction, and then I will talk about the experiments which we have carried out, and then I will go to the results, and I will go to the conclusions part. The paper-based electrochemical biosensors are the current interest because they are, as I said, they are environmental friendly, they are flexible, and they are wearable biosensors. So people are interested in this area of the biosensors, and the electrochemical flexible electrodes are more adaptable as compared to the conventional techniques that are normally used in labs like ELISA or any other methods. So because they are highly sensitive and they are portable and they are low, they need lower production cost, and in situ detection can be taken, like if the person is lying on the bed, and we can make the wearable device on him, and then we can take the we can measure the cholesterol levels. Therefore wearable devices are the much of interest. So therefore many research groups are attracted to this area of research, and people are working on on developing the biosensors for monitoring frequently required analytes, like the analytes for which the monitoring is frequently required, like glucose, cholesterol, urea, uric acid, etc. In the present work, we have focused on the cholesterol sensing. Why cholesterol is important? Cholesterol, if the cholesterol level increases in the human body, then it causes very severe diseases like cardiovascular diseases, heart problems, blockages. Sometimes it can be fatal by causing heart attacks, etc. Therefore the measuring of cholesterol is very important, and the cholesterol level in a healthy human being must be between 4.5 to 6.2 millimolars. If it is more than that, then it can cause to very severe diseases like paralysis, strokes and all, hypertension, cerebral thrombosis, these kind of things. Therefore it is very important to measure cholesterol time to time, so that we can prevent the fatality. So for developing the cholesterol biosensors, enzymatic approaches are used as the conventional methods, because these are very easy to fabricate and cost effective. Therefore, here in this present work, we have used the cholesterol oxidase enzyme for developing the sensor, for developing our sensor. And between the electrode and the enzyme, there should be some attaching material, like the electrode is made up of carbon ink, as I said, and to attach the enzyme to the carbon ink effectively, some kind of nanomaterial should be required. In this present work, we have used the nanomaterial as the graphene oxide and polyaniline composite. Why we have used this? Graphene oxide is having so many functional groups attached to that, so that enzyme can be easily immobilized on graphene oxide, and polyaniline is very electroactive polymer, which can give very good electrochemical properties. Therefore the combination of this composite helps in getting a sensitive device. The experimental work which carried out is the polyaniline graphene oxide composites were prepared. For that, graphene oxide was synthesized in the lab using modified Hammer's method, and polyaniline was procured from Sigma. And the polyaniline powder and graphene oxide both were dispersed in DMSO, and both were added together, and they sonicated for a few hours so that the composite can be formed uniformly. So we got the uniform composite dispersion, and then we took the before that we have designed the sensing electrode design as shown in the figure. Like here we have made two electrode system in which the circular portion shows the working electrode, and the half circle portion shows the counter electrode, and these are the connecting pads to the adapter. And on for that, first the stencil has been designed to make this design, and then it was printed using screen printing technique, and then the polyaniline graphene oxide composite was drop casted on the working electrode. Once the polyaniline graphene oxide was drop casted, then the next step is to immobilize the enzyme. The cholesterol oxidase 1 milligram per ml was taken, and this was drop casted on top of this graphene oxide and polyaniline composite. As graphene oxide and polyaniline composite has many functional groups, no need of any mediator required to immobilize the enzyme on the electrode. So this is the electrode which we made, and these red lines are the wax lines. These are made because the paper is hydrophilic in nature, and if we put buffer solution on this, that can be adsorbed and it can travel through. Therefore we want to stop that. For that we have used the hydrophobic wax coating, and then we have heated the electrode after coating so that it can make a barrier for not flowing the buffer solution above this area. Therefore this is the electrode which we have used, and we have carried out the first step of testing, in which what we have done is we have taken the cyclic voltammetry measurements at each step. First one is the bare electrode, that is the just a carbon electrode, this one, and then we have put GO on that, and we have taken the cyclic voltammetry measurements, in which there are no good peaks, like it did not show very good property, very good electrochemical property. After that we had put polyaniline itself, and it did not give very good current. Therefore the GO-Pani composite was put, and this blue curve shows the GO-Pani composite. We can see the cyclic voltammetric curve here, and then after immobilizing the cholesterol oxidase, the current is further increased, and this light blue color curve shows the cyclic voltammetry of GO-Pani CHOX electrode, and upon that 15 millimole cholesterol was added so that the current was increased drastically. That means this electrode is good for sensing the cholesterol. After that we have before that we have characterized the graphene oxide. As graphene oxide was synthesized in the lab, it was characterized using XRD. The peak at around 10 degrees shows that the graphene oxide peak, and it is confirmed from this. The Raman studies also shows the peaks at these characteristic peaks are shown, the G band and D band, which is further confirmed, and then the FTIR shows different functional groups present in the graphene oxide, showing that the graphene oxide is formed. So this is the SEM image of graphene oxide and polyaniline. We can see that the graphene oxide layers are visible, and in between the polyaniline is also visible, and the layers are quite thick, implying that some polyaniline is present on top of the graphene oxide layers also. So this is the SEM image of the composite, and then we have taken the electrochemical response studies. In these studies, first we have done, what we have done is we have taken the enzyme electrode and we have carried out the scan rate study at different scan rates from 10 millivolts per second to 100 millivolts per second, and the scan rate shows that the current is increasing with the scan rate, which implies that the process, the charge transfer process which is taking place in the present study is diffusion controlled. And we have done the cholesterol cholesterol sensing using different concentrations of cholesterol solution, like 1 millimole, 2 millimole, 4 millimole, up to 10 millimole, and the change in the current is clearly visible in the cyclic voltammetry studies. And further, we have taken the chronoamperometry studies also at different concentration of the cholesterol, and again the increasing trend of the current is observed as shown in this figure, and the calibration plot was made using this values of the peak current. So the calibration plot showed a good linearity, and the sensitivity was calculated using the calibration plot, and it was obtained to be 0.652 microampere millimole inverse centimeter to the power of -2. So it showed a very good sensitivity, and the electrochemical screen printed paper based analytical device was fabricated. In future we are planning to make a device which can a portable device on which we can measure the cholesterol in the human serum. Thank you for your attention. This is my lab members. I am thankful to all of them. Thank you very much.